A warm welcome to one and all. Today let's discuss about thermal processing option and case studies. Myself Dr. V. Godwin Sharmila, Associate Professor, Department of Civil Engineering, Rohini College of Engineering and Technology. Thermal processing option. There are various thermal processing options such as gasification, pyrolysis, incinerations are available. First, let's see about gasification. The gasification is nothing, a thermal degradation of the waste material which are rich in hydrocarbon, that is the carbon, hydrogen and oxygen molecule is get transformed into carbon dioxide and water under insufficient supply of oxygen. So that means there occur a partial oxidation, so that the composting gas which obtained usually consists of hydrogen as well as the carbon monoxide. So the oxygen which is evolved in the air must be pure oxygen or in the form of steam. Usually this gasification process occurs at the temperature range of 700 to 1600 degrees Celsius. During the gasification process, the steam is injected continuously into the gasification reactor to evolve the generation of carbon monoxide and hydrogen. So the main reaction that takes place during the gasification process are oxidation, water vapor reaction, which is an endothermic reaction, and finally the expulsion of carbon dioxide and hydrogen, which is an exothermic reaction. In this, the proper supply of oxygen, that is the proper supply of steam, is the major factor which determines the efficiency of the gasification process. Then thus finally the obtained carbon dioxide, hydrogen, methane during the process of gasification is considered to be the syngases, whose heating value is about 4 to 10 mg per meter cube. So the raw syngas gases which was exist in the gasification process must be cleaned up with necessary equipment and can be utilized for the generation of the power, usually which is utilized for the preparation or the production of the electricity, which is another form of source of energy. So this energy can be converted to this electricity and it is sold in the form of grid. Next method is the thermal degradation. In this, the carbon based material are directly or indirectly heated by at the temperature of about 450 to 750 degrees Celsius in the absence or complete absence of free oxygen. So during this burning of the organic waste in the absence of the oxygen, a carbonaceous char, oil or combustible gases are evolved. So this is used for the organic material volatilization, which resulting in the generation of the syngas, and the primary composition of the syngas is hydrogen, carbon monoxide, carbon dioxide, methane and the complex hydrocarbon. So the initially decomposed one organic matter is converted into low volatility and then to the more volatile one by proper providence of the temperature increment within the organic substances heating. So that the early stages of the combustion process, the condensation and the hydrogen removal is a major factor which may induces the low volatility, and after the proper enhancement in the temperature, the hydrogen removal and the ring formation reaction leads to the generation of the better thermal degradation process. Next stage is the incineration method of treatment. The incineration method of process is the proper management of the solid waste, that is or the proper combustion of the solid waste in oxygen rich environment. So continuous supply of oxygen has been provided during the process of incineration and the temperature was maintained higher than 850 degrees Celsius. Here the net product or the net gases which was obtained consist of carbon monoxide, carbon dioxide, nitrogen dioxide, water, sulfur dioxide, ashes and heat. So the power plant which has been utilized for the incineration purpose is highly enhances the generation of the energy. So the proper cleanup or the proper monitoring of the incineration and the heat recovery should be maintained during the stages of the incineration process. So in the lack of oxygen, the impartial combustion may occur, which leads to the generation of the carbon monoxide. Advantages. These are the some of the advantages of the incinerator. It requires only less land because it is a like of small setup of chambers, and it does not have any heavy duty hauling machines. It can be handled by the short hauling machine, and also the ashes and the residue obtained is free of organic content, and it is non-combustible. The climate and usually the weather condition will not interfere during the process of incineration process. There is no restriction for its operation. So the income has been obtained in the form of heat, or the power can be generated by means of the incineration process. Disadvantages. The disadvantages are, it is the initial cost of constructing the incineration plant is high, and also the operating cost is relatively high. This operation and the maintenance of the incineration process require highly skilled employees. Case study. Let's see some of the case studies under the Indian condition. We know the municipal solid waste that we are generating throughout the India is high, since it was a developing nation, and the peoples has been moving from one area to the another area due to the presence of excess population as well as the urbanization. So the India is generating about 145 million tons of waste per year, and which is reaches in the future is about 260 to 300 million tons per day. So based on the data which is obtained from the Central Pollution Control Board, about 117 1,17,644 million tons of waste has been collected, and around 49,401 million ton is only treated. So the thermal degradation process, incineration, pyrolysis, plasma or gasification is highly implemented in India to reduce those waste. But as for as based on the condition of the India, the incineration process is not much suitable, since the most of the waste which were obtained from the India, or which was generated during the Indian condition, is highly of moisture content, which is about in the range of 30 to 60 percentage, and whose calorific value is about 800 to 1100 kilocalorie per kilogram in solid. So for burning the hospital waste only we are utilizing the small incineration. And also in Delhi there was a municipal solid incineration plant of capacity 300 TPD capacity, which was highly implemented for reducing the waste for a longer run, and it was having the record calorific value, and there was a no large scale working of these municipal solid waste incineration technique in India is explored at now. Then the gasification. The gasification is also a one such thermal treatment process which was highly utilized in the India, but it was installed in the limited amount. So the most of the waste which was banned in the gasification process are the agro biomass. This was highly installed in the Nahur, Kanugar, Rajasthan, but now by Navarat Energy Research and Information for burning the agro waste, sawmill dust, forest waste. And also the Tata Energy Research Institute has also installed a gasifier at Gaul Bahari campus in New Delhi. This is one of the it can also be utilized as the incineration also. Next, the incineration process which was installed was highly utilized for degrading the feedstock that was in the form to produce the heat and electricity. So the burning of those feedstock is usually carried for the temperature of about 850 degrees Celsius in the presence of oxygen. The final product obtained has been removed properly Usually the types of incinerator which was existing in the Indian condition are the fluidized bed, rotary kiln, fixed grate, moving grate. So the hospital and the biological treatment process are mostly utilized in the incineration process. So the major residue which was obtained in the form of fly ash or the block is utilized for the road construction purpose. So in the installation plant which was established in the Delhi in year 1987 has a capacity to handle 300 tons of waste per day, which can generate the electricity of 3.75 megawatt. Due to the low calorific value, thus and the improper climatic condition, the investment gone wasted since the due to high moisture content, the low moisture content and the high excess heat generation, the calorific value was reduced uh, very low since the incineration process required the calorific value of 1500 kilocalorie per kilogram. The pyrolysis techniques which are highly implemented to treat the hazardous waste, it requires the classification. It has major classification, but the pyrolysis are requirement of the proper pyrolysis of the waste is high capital cost, but it was usually treated in the absence of oxygen. So the process convert the solid fuel matter into different byproducts such as the syngas, liquid, and biochar. So these there are two type of pyrolysis, fast pyrolysis, which was used for the bio-based oil and also for the generation of the charcoal. So the pyrolysis pre-treatment which was utilized under the Indian condition for treating the hazardous waste has too few advantages since this waste cannot be released. The waste which is obtained as a byproduct cannot be released as such to the environment due to the generation of the carbon monoxide during the treat process. Hence, the plastic waste can also be treated using the pyrolysis, but the generation of the bad excess gases and oil during this techniques with the good calorific value cannot be disposed as such into the environment. Thank you.